So, good afternoon to everyone. Welcome to the food section of the natural products applications. I am Sandrina and I will be moderating this first part of the foods area. This first part will be composed of 2 keynotes and six oral presentations. Afterwards, we will have a short break and we will then continue with the pitch section. Just to remind you that you can take a look on the posters that are in the website of the Congress. The Congress is also transmitted in the YouTube channel, where you can also use the chat to perform your questions that will then be addressed to the speakers so they can respond to all your questions. So we will start with the keynotes presentations that will have about 25 minutes and will be followed by a 5 minutes discussion. So we will start with the first keynote presentation. It is for me a great pleasure to present you Professor Manuela Pintado. Professor Manuela Pintado has a PhD in biotechnology in the specialty of engineering and food sciences. Currently, she is a professor at the Faculty of Biotechnology at the University of Porto, where she is also the director of the Biotechnology School and of the Biotechnology and Chemistry Center. Pleasure to present you. In the research field, she is the coordinator of the group of biological-based products and leader of the thematic research laboratory for bioactive and bioproducts. Professor Manuela Pintado is also a member of the IBET Advisory Board, a member of the Strategic Group for Agri-Food, Forest and Biodiversity, and member of the Strategic Group for Circular Economy, Vice President of the Scientific Council for Natural and Environmental Sciences of FCT. She is also the coordinator of the Evaluation Committee for the final reports of FCT, Vice President of the European Chitin Society. Professor Manuela is also the president of the group of bioactive compounds of the ISECI Food Association since 2014. She was also the coordinator of the Department of Science Services of the industry. From her research work, she has also until now published hundreds of scientific manuscripts that lead to a recognition by the Ciência Viva program as one of the female faces of the Portuguese science community. So I think this will be a very interesting keynote for us to listen. So Professor Manuela, you have the word.
Oh, thank you, Sandrina. I think it's a lot of names, and in fact, I'm just a simple researcher, loving this area of antimicrobials, and that's among our research studies. We have been isolating a lot of bioactive components, and today I'm going to present you some antimicrobial solutions have natural, in fact, that we have been applying to different food applications. So it's a pleasure to be here today. I want to thank the organizing committee that invite me, and of course to CIMO and all the other institutions that are integrating this fantastic event. So just moving fast, we are dealing today in food systems and food area challenges to the 2050. We have, in fact, a problem with the consumer that at the moment is not just so passive. He's looking every day to the labels, is analyzing the labels, and is really aware of the interrelation between the food, the health, and the well-being. So in fact, for him now to have a specific diet, to have a specific food, is really important because he understands that there is a very direct influence of the food and his health. So at the same time, they are requiring special nutrients, special ingredients to improve some chronic diseases. But today, especially, I'm going to talk more about preservation. So we need also to deal for this future about the public health regulations and policies that in fact are imposing to the food industry with a lot of constraints, especially with additives. So in fact, the artificial is a public enemy for food industry. They are dealing with this problem because in fact nobody wants in nowadays to see synthetic compounds in their food products. So consumers are increasingly looking for natural and less processed food products. So the food preservatives in fact has been dealing with a problem for food industry because since some years ago, I think everyone is concerned about several of the synthetic preservatives. Yes, because they have been associated with different cancer and different health diseases. And this is in fact a problem because the industry in some cases they were only knowing and applying synthetic ingredients, and suddenly they need to fight with this problem. They need to find new natural solutions. And of course, when we talk about synthetic additives, it's easier because they are very concentrated, they are very specific in targets, but in fact then it's very difficult to replace them because in natural ingredients or additives we don't find such specific components because you have mixtures, you'll see. So in fact, the most of these current solutions are a problem for the consumers, for the industry. So we need to increase what we call in nowadays a great demand for the clean label. And that means less additives and less synthetic preservatives and much more natural foods. So the clean label is increasing every day. So I would say that at the moment all the processing industry, food industries are thinking about the clean label, not only to reduce the preservatives, but also all the other negative ingredients or additives like the sugar, the salt, and so on. And in fact, when we look to a food product and we look to the label, we want to see just natural things. Every consumer is avoiding GMOs. Every consumer is avoiding pesticides and just looking to see no preservative and natural ingredients and additives. This is a challenge because when we move from an antimicrobial in the food product and we take salt and when we take some specific synthetic antimicrobials, then it's very difficult to maintain the safety of this product. Sometimes we can maintain the sensory, but then the safety is a constraint. And in fact, is compulsory for the food industry to put all the products in the market with the required safety, because otherwise it would be a very serious problem for them. So in fact, during the last 10, 20 years, there has been a long list of researchers working with antimicrobials or natural ingredients and natural additives. So when you talk about natural additives for food applications, usually one of the most important, in fact, are antimicrobials, but also very related with them, we have antioxidants. In fact, most of the antioxidant uh, extracts from different sources, they are also have sometimes these antimicrobial properties, so are really related. But also related with these natural antimicrobials, we also consider from natural sources other agents, ingredients, like texturizer, colors, and so on. So in fact, today I'm going to focus on especially preservatives. And when you talk about preservatives, you talk about antimicrobials and antioxidants. Of course, when you talk about food products, as you know, we have a huge range of food products, and especially those that are not so processed, that we sometimes call fresh products, and with a very short shelf life. These food preservatives, antioxidants, and antimicrobials are in fact very, very important. And we are talking about cheese, meat, some fruits, fish. So when you talk about these food products and then even the processed products, we need to find solutions to replace the synthetic preservatives and replace with some natural sources. So when you talk about these natural antimicrobials, we usually focus in some groups of components. We are talking some of them already in the market about enzymes. Especially we have important levels of enzymes in milk, for instance, but we also have already purified enzymes like lysozyme, lactoperoxidase. They are natural antimicrobials. But also we should include important polysaccharides that we have in nature, especially one of that I'm going to talk today is chitosan. It's very important and quite increasingly used in the food industry. We also have some natural components we call usually bacteriocins, but also organic acids produced by bacteria. And then we have what we call all the world of plants, fruits, all the vegetables. Most of them, they have very interesting components that can be extracted and produce with them some natural preservatives. And you talk about these components, especially rich in polyphenols, sometimes carotenoids, terpenes. Terpenes, we'll talk, they are really important. And all of them in a synergy sometimes in these natural antimicrobials, we can have a combination of different efficacies, and you can sometimes replace some of these synthetic antimicrobials. And when we include in these food matrices, what you want in fact is to prevent the food pathogens and contaminants, and of course as much as possible for the food industry to increase the extension of shelf life. This is also a very important topic that is not the topic today, but we must remember that for food industry, anytime that you can extend the shelf life, we are saving losses and wastes. That is also a very important topic. So when we try to have new preservatives to support an extension of shelf life, we are also saving the planet. So it's a very interesting relationship. So today, I'll trying to give you some examples about our long research studies in these fields. So, and I will give different examples. I'm not bringing all of them, but at least very different case studies in order to show how broad can be the source of these preservatives to use in food applications. So I'll start with plant extracts and fruit extracts. I'll talk also about byproducts, extracts, where we have been working a lot, and also from the byproducts, some peptides and chitosan. And just to finish, I'll give you also an example of how bacteria as a microorganism can be also a source of antimicrobials. So when we start these studies, we start around the first publication, I think, in antioxidants and related with the plant extracts in 2007. We saw that, in fact, several of Portuguese plants, we started with 40 different plants. We extract aqueous extracts, and then we saw that some of them, in fact, they are they have specific antimicrobial activity against different food pathogens like staphylococcus, and usually the plants, or most of the plants enriched in polyphenols, the main targets are gram-positive bacteria. Of course, as you'll see during our studies, we can also find some specific extracts also targeting gram-negative, but especially the most relevant group of bacteria for polyphenol extracts from plants are usually gram-positive. They are really active. So here we have very interesting against the Staphylococcus aureus in food products, or Listeria innocua. I don't have here results, but usually they are also active against Bacillus cereus. And in this case, we could, from this part, understanding some of these plants, we could select some interesting extracts to incorporate in food products. But we have problems with these natural extracts, with these natural enriched polyphenol extracts. In fact, we understand that when we incorporate them directly in some food products, it's difficult because polyphenols interacts a lot with proteins. So when we have enriched food matrices, or enriched protein food matrices, sometimes we understand that some of the polyphenols can be lost and lose also the preservative activity. So this was a research project coordinated by a researcher of my team, Raquel, and where we try to use some of the previous extracts, the sage and savory extracts, especially rich in rosmarinic acid, and we try to develop solutions to incorporate in dairy products. And then we understood that when we put directly these extracts, in fact, they were destroyed, part of them, because they were interacting with milk proteins. So here we try to minimize impact. And so several times we need to encapsulate these polyphenol extracts as natural preservatives to preserve the activity. Although we expect to expand or extend the shelf life of the products, we also aim sometimes with these antimicrobial extracts to have health benefits. So at the same time they can inhibit pathogens in the food products, we can also use these solutions carried in the food products to inhibit some of the food pathogens in the gut. And this was the objective. So using also these extracts to produce antimicrobial particles, antioxidant particles that could have benefits directly in the gut. So here we were developing carriers to support these antimicrobial antioxidant extracts. In this case, we have been developing solid lipid nanoparticles, very interesting, very high encapsulation efficiencies. We could dry these particles, and then we could incorporate them in yogurt. And we could see that these particles were not affecting the microbiological quality of yogurt, that, as you know, probably we need to have the specific yogurt bacteria at levels higher than 10 to the 6, so we could maintain with these particles the stability of the yogurt. But also we could then demonstrate that these particles throughout the gastrointestinal tract, they were released specifically in the gut, and where these polyphenols, specifically the high level of rosmarinic acid, was released to have antimicrobial activity just against pathogens and selectively not affecting our natural microbiome in the gut. Also, we have been studying not only aqueous or ethanolic extracts, we also have been extracting, in this case, essential oils from aromatic plants, some very known, as you know, coriander, petrosilio, but also some native, like carqueja in Portuguese, this pterospharum and oxínio. And in this case, what we have been doing after this oil extraction was also to try to encapsulate. And why? In fact, when we look to the essential oil, is in fact, for me, from a microbiologist perspective, in fact, they are really a very relevant antimicrobial agents. They have a broad spectrum. They are active against gram-positive, gram-negative molds, yeasts. But in fact, they have a problem that can be a benefit because we can include this as a benefit due to the aroma of these essential oils. But at the same time, for some type of products, we don't want this specific flavor. So we want activity, but we need to reduce sometimes this aroma to avoid and to constrain this problem in the final food product. So in this case, what we try to do here was to encapsulate in cyclodextrins with a high efficiency. In this case, the system is a good system either for essential oils or for aqueous extracts. And it is a very easy technique to encapsulate. And what we were demonstrating is that after encapsulation, in fact, the aroma is reducing. So when we buy the product, the aroma is not so strong. But when we ingest this product in the mouth, we can have a release of these aromas in the same way. So we can increase the aspect and the sensory quality visually of the product, and at the same time can have also this strong flavor. However, this case is specifically interesting as a flavor antimicrobial at the same time to develop new products, but we always even encapsulate, we cannot eliminate completely all the aroma from these products. In some cases we can reduce. However, these capsules were really interesting. We could develop a fresh cheese, spread cheese, butter, and also pate. And what we were analyzing in these food products is, besides we can have interesting sensory properties, we could significantly increase the shelf life of all of them, especially the pate that has the fresh pate has a very short shelf life. And also we could avoid oxidation. So at the same time, we could avoid lipid oxidation, and especially for the pate was really interesting because we could maintain much more the natural flavor of meat, avoiding this lipid oxidation. Also, throughout our studies, we have been working with native products in Portugal. So a corn from the cucasuber and ilex. We have been studying different parts of these fruits. We have been studying especially roasted the cotyledon. We have been producing coffee, and from these products we have been trying to understand. And in fact, this extract is really a strong antioxidant. It's very rich in tannins, and we demonstrate even the spread is also quite focused on gram-positive bacteria, but we have a very interesting spectrum of antimicrobial activity with it. We can see here, for instance, a listeria, listeria in this case is innocua, but the result is the same for monocytogenes, is one of the problems of the food industry. And you can see here in just 2 hours, the roasted extract rich in polyphenols from this corn, we can inhibit it completely high levels of listeria. So it's a very active antimicrobial extracts. Also from fruits, we have been working with a company. They are producing a lot of stems. So stems during the sour cherry, who is Portuguese, maybe knows the name of ginja. We have been producing extracts from the stems. They have a tons and tons of this waste. So when they produce this very interesting sherry liquor, they have in each summer tons of stems, and we were producing natural antimicrobial extracts with it. We could demonstrate a strong efficacy. In this case, we were selecting different solvents. Of course, we tried to use solvents food grade, although the ethanolic extracts were good. The best one in this case was ethyl acetate, and we were then incorporating these extracts in carboxymethyl cellulose antimicrobial films. So we can see a very interesting thing. In this case, these extracts, beside all the gram-positive bacteria, they are also interestingly active against the Salmonella enteritidis, and it's really not so common. So we could see here also a spectrum for this type of bacteria that is, as you know, is a quite critical bacteria for gastrointestinal infections. So in this case, we can see that based on these films, edible films of carboxymethyl cellulose, we could inhibit most of the agents that we were studying. In this case, you can see how listeria was reduced just in 2 hours. So salmonella also, and we can demonstrate that if you wrap or if you produce a coating for different food products, we can in fact inhibit the contamination and the growth of these food pathogens. Also, when we talk about these natural antimicrobials, sometimes we use them to eliminate or to reduce contaminants in the food process. This is an example, a collaboration with our colleagues from the wine department. And we can see here how also these sour cherry extracts and also others that we were studying at that moment that I didn't bring today, blueberry extracts, you can see that we can reduce and eliminate completely some of the most important contaminants in the wine, like the Caras, different Caras and Brettanomyces, that were completely eliminated. So it's also a strategy not to eliminate just food pathogens, but can be very relevant for the quality of the food products to reduce the contaminants throughout the process or the aging of a specific product. Also, talking about continuing with some byproducts, we have been studying different types of fruits, peels. I just giving you an example. This is a pomegranate peel extract. We sometimes we have collaborations with different colleagues with different technologies. In this case, this pomegranate peel extract was produced in collaboration with our colleagues in Aveiro, Jorge Saraiva, using high pressure. And in this case, this extract was then, after characterization and demonstrating its antimicrobial activity, we have been using to reduce the contamination in carrot juices. Carrot juices is a juice with high pH, so it's quite prone to the contamination. For instance, in orange, we have pH is around 3.5. In carrot, we have higher pH, so it's more prone to be contaminated. And we have been using this extract to enrich these juices. On one side, we are adding antioxidant activity, and on the other side, we are increasing the shelf life. So in this case, we can see here that after 28 days, this is a minimum processed juice, so it's not ultra pasteurized, it's just pasteurized. And we can see that just after 28 days, we can decrease the level of contamination. So, and in this case, we demonstrate, and we were also then prolonging the shelf life, that sometimes prolonging 1 or 2 days the shelf life of the food product is very important economically for a company. So even 11% is not so much. In this case, 1 day, 2 days, 3 days, 4 days are really important for a food industry because they can save a lot of money. And especially, as I told you previously, we can save a lot of losses and waste. That is also really important for the food industry. So also different, moving to another ingredient, we have been working with whey as a byproduct. Yeah.
Sorry to interrupt you. 2 more minutes. Okay.
Okay. So maybe I'm moving to just to show you antimicrobial activity. And here is just to show you that antimicrobial peptides can be also very relevant. In this case, we have peptides obtained by ultrafiltration. And in this case, this is an example of 2 different extracts, one with lower molecular weight, 1,000, and another one, 3,000. And you can see how these peptides can inhibit completely different microorganisms, gram-positive and gram-negative too. So also just to, we have been chitosan, just to show you some examples, we have been producing in this case. You can see in these pictures, in these photos, some images with how chitosan is destroying on the right the different Staphylococcus aureus, and you can see that we can incorporate, in this case is an example where we were incorporating in goat sausages as an antioxidant and as a functional ingredient, but also we could extend the shelf life of these specific sausages, or can be incorporated in coatings. We did this for cheese, or we can even produce chitosan nanoparticles that can be also be used. In this case are nanoparticles produced with ionic gelation, and we could demonstrate they can be released in the gut after gastrointestinal tract, and we can have effective antimicrobial activity in the gut against different E. coli, Staphylococcus, in this case Yersinia, Salmonella, reducing 99% of these bacteria. So in fact, we can have also effect at health level with this antimicrobial. Just leave you with some images showing how these particles can in fact, and I would stay here because I don't want to delay the program. So 5 minutes for questions are really crucial. I'm open to respond all your questions. Thank you so much.
Thank you very much, Professor Manuela, for your wonderful presentation. I think we have no questions from the audience for you. So just in terms of curiosity, I wanted to ask you about your so interesting research you have been explaining in this keynote. In your opinion, what do you think that are the main challenges when we want to transport all this technology to the industry, for the food sector, for instance? It's a neat process, or in terms of legislation and so on. What is your experience?
First of all, when you talk about natural antimicrobial, especially natural extracts, we have a problem that is to standardize these extracts. So, because when you take extracts from the plants, especially plants changing every year according to climatic conditions, according to soil. So 1 year we can have a strong antimicrobial agent, and in the other year we can reduce this activity. So to guarantee that we have a standard extract to commercialize is very difficult. So one of the first points to produce the extract is this one. And then another point that is when we try to integrate this in the commercial in the market is really difficult due to the regulation, as you mentioned. In fact, we have a list of additives, and to enter in this list of additives takes a long time. So sometimes the strategy that the industry of ingredients have been using is, instead of entering there directly as an antimicrobial, that is much more difficult. Sometimes we have an additive that is a flavor. Okay, and at the same time, this flavor takes a lot of components that are antimicrobial, and we can sell this as a flavoring, and at the same time we can have impact in the microbiology of the final product. So this is a strategy, but in fact is a barrier. So I would say that the standardization of the ingredient, the antimicrobial legislation for food products is another barrier. And I would say finally is that some of them also constrain the sensory, and also in some cases are not compatible with all the food matrices. So we must be aware to select the adequate matrices, and if it's not adequate, we need to encapsulate, or we need to carrier in a film, for instance, depending on the applications. On the other side, we must be aware that in some cases we need to have antimicrobials compatible with the final sensory properties. And this is also sometimes I think industry has a lot of experience, and in some cases we can mask, but not in all. So I would say that these are the 4 main barriers I consider for these natural antimicrobials.
Okay, thank you very much, Professor Manuela. I think Professor Jesús Simal also wants to make you a question, so I will pass the word to him.
Yes, thanks, Sandrina. Manuela, was a very interesting lecture with a lot of data. You have worked with nanocarrier systems for the natural ingredients, encapsulation systems, and I wonder if you have also experience with packaging, intelligent packaging and nano delivery systems into the food. In this case, you can reduce the dose of the natural ingredient and maybe reduce the level of flavors. What do you think about?
Yeah, well, I have been working more with edible films directly, so incorporate directly the natural extracts, and then the film itself releases when in contact with the material, the food matrices. But in this case, we also have been developing some films incorporating nanoparticles. I believe that is one of the features, because when we want to produce active packaging, releasing aroma, but especially antimicrobials, antioxidants, I believe that the nanotechnology, and I would change now because nobody in food industry likes to talk about nano, no? So now we need to move to the micro technology, but I would say that microparticles with the active agents to preserve the food, incorporating packaging is in fact one of the future for food industry. I agree with you.
Thank you.
So thank you once again, Professor Manuela, for your wonderful presentation in our Congress.
Okay, thank you, and I wish you all the best and for your conference, and learn a lot. Bye-bye. Thank you.
Thank you. Bye-bye. So now we can move on for the next keynote. It's also my pleasure to present you Professor Jesús Simal. Professor Jesús Simal is a full professor in food science at the University of Vigo. He is also the leader of a research group of excellence at Galicia. He is also the leader of Environmental, Agricultural and Food Research Center formed by 10 research groups from different fields. And he is also the head of the Department of Analytical Chemistry and Food Science at the University of Vigo. So, Professor Jesús Simal, you have 25 minutes, more or less, to perform your presentation. So I will pass you the word to hear your interesting keynote.
Yes, can you see my presentation?
There we go. That's it.
Yeah, okay, thank you very much. I want to thank to the organizers because I'm very happy to be here, even online, and be part of this interesting Congress. My talk is about metabolomics, the basics and applications in food and function, and also medical applications. We intend to define what is a metabolome, to see the importance of potential application of metabolomics, to talk about the operational principles of the main technologies, and also to understand the difference between targeted and untargeted metabolomics. If we see the pyramid of life, in the base we have the genome, then in the upper part proteome, and in the more upper part metabolome, and the influence of physiological and environmental factors are higher in the upper part of the pyramid. What is a metabolomic? A metabolome. Genomics is the field of life science that use high throughput technologies to identify all the genes in a given cell, tissue, or organism. That is the genome. In that way, metabolomics is the field of life science that use high throughput technologies to identify all the small molecules of metabolites in a given cell, tissue, or organism. That is the metabolome. But why is metabolomics so important? Because metabolite, it can be any organic molecule that is detectable, usually above picomolar in the body, with a molecular weight lower than 1,500 Daltons. Includes peptides, oligonucleotides, sugars, nucleosides, organic acids, ketones, aldehydes, and along, etc. Includes both human and microbial products. It should be detectable. Can be detectable above 1 femtomolar, 1 picomolar, 1 nanomolar, depending on the technique. Then what is a metabolome? The complete collection of a small molecule metabolites in a cell, organ, tissue, or organism, but includes both endogenous and exogenous molecules, as well also as transient or even theoretical molecules. The molecules that can be detected are very dependent on the detection technology. That is the reason we say that the metabolome size is always ill-defined, very poorly defined. If we look at the pyramid of life, we see that many food-related products have different metabolites. In an order of magnitude, for example, plants are already well known, 200,000 chemicals. For microbes, 60,000 chemicals around. And for mammals, at least 20,000 chemicals. There are a lot of databases for metabolomes. There are databases for toxins, environmental chemicals, for drug metabolites, for drugs, for food additives, for phytochemicals, for also endogenous metabolites in the range of femtomolar to molar. But there are also theoretical human metabolomes, like those formed by lipid and lipid derivatives, also those formed by drugs, from food components, food ingredients, and also secondary endogenous metabolites. Why is metabolomics important? Because small molecules count. More than 95% of all diagnostic clinical assays test for small molecules. 89% of all known drugs are small molecules. 50% of all drugs are derived from persisting metabolites. 30% of identified genetic disorders involve diseases of small molecule metabolism. Small molecules serve also as cofactors and signaling molecules for thousands of proteins that also are with enzymatic or metabolic activities. We say that metabolites are the canaries of the genome. You know, this bird, the canary, is a very sensitive bird. In this way, we say the metabolites are the canaries of the genome because a single base change in the DNA can lead to 10,000 changes in metabolite levels. For example, the response in time of the genome can take days, weeks. The response in time of the proteome can take days, hours, but the response in time of metabolomics, of metabolites, can be in just seconds, minutes. It's very fast, the response. The key question is that it's not so easy to understand the whole thing of metabolic pathways, interconnection of metabolites. It's a really complex picture. But the interconnection between genome, proteome, and metabolome can help us in this process of understanding metabolomics. The metabolome is connected to all other omes because small molecules like adenosine monophosphate, cytosine monophosphate, guanosine monophosphate, etc., are the primary constituents of the genome and transcriptome. Small molecules, like the 20 amino acids, are also the primary constituents of the proteome. Small molecules, like lipids, give to the cells their shape, form, integrity, and structure. Small molecules, sugars, lipids, amino acids, adenosine triphosphate, are the source of all cellular energy. Small molecules, too, serve as cofactors and signaling molecules for both the proteome and the genome. That is why we say that the genome and proteome largely evolved to catalyze the chemistry of all small molecules. The interplay connection between genomics, proteomics, and metabolomics with the help of technology, information, and communication tools like bioinformatics or cheminformatics can help us to understand the system biology. The metabolomics workflow is that way. We start with a biological tissue, a food sample, we do extraction, we analyze the structs with different techniques, and then we need to do biological interpretation of all data obtained. But why metabolomics is so difficult? Because genome is just a matter of 4 bases in the base of the pyramid. Proteome is proteins are constructed based on 20 different amino acids, but metabolites are a large quantity of molecules, 200,000 molecules. The chemical diversity can increase from the lower part of the pyramid to the upper part of the pyramid. We have a lot of different techniques to understand metabolomics. We have ultra performance liquid chromatography, capillary electrophoresis, microfluidics, different combinations with mass spectrometer detectors, nuclear magnetic resonance spectroscopy, X-ray crystallography, laser-induced fluorescence detection, and etc. For example, in chromatography, the basis is we have a stationary phase, a mobile phase, a column, we inject the sample, we have a partition between both phases, and we have a retention time for all the components, and with appropriate standards, we can identify the molecules in a certain sample, and measuring the area of the signal, we can also relate to the quantity of the molecule. If we use mass spectrometer detectors, at least the molecular weight of the different components is very characteristic for these components. But when we use a mass spectrometer detector, we don't use the average mass, that is the weighted mass of all isotopic components, like the one in red. We use the monoisotopic mass, the mass determined using the masses of the most abundant isotopes. And usually we have an isotopic distribution. To see this isotopic distribution, we need high resolution instruments. For example, a time of flight mass spectrometer is 10 times higher resolution than ion trap mass spectrometer. Here in the ion trap, we cannot detect the isotopic distribution, but with the time of flight, it is possible to see that isotopic distribution. In electronic path, when you use a gas chromatograph with a mass spectrometer detector, for example, if we want to detect the spectrum of methanol, we bombard the methanol with electrons. We take one electron from the molecule, we have a molecular ion, and this is fragmented into the most stable cations. We have a unique fingerprint for this component. It's like a digital track for that molecule. That is also very characteristic. In NMR spectroscopy, nuclear magnetic resonance measure nuclear magnetism, or better to say, change in nuclear magnetisms in a molecule. NMR measures the absorption of light, radio waves, due to changes in nuclear spin orientation. NMR only occurs when a sample is in a strong magnetic field, and different nuclei absorb at different energies, frequencies. For example, we need a magnet to expose our sample to the magnet, and increasing magnetic field strength, we have also higher sensitivity to detect lower amounts of the different components. If this is a typical NMR spectrum, we have trimethylsiloxane in a proton NMR at a reference material with 0 chemical shift. And then we have different chemical shifts for the different functional groups at different frequencies. We have also a splitting pattern produced from the spin coupling that is due to the environment of the functional groups within the structure of the molecule. And we have also different peak intensities depending on the amount of functional groups in the molecule. For example, we have trimethylsiloxane with 0 chemical shift and different functional groups with traditional frequencies that are characteristics for them. In this case, then we can interpret a spectrum like that one from ethylbenzene. This is the signal for benzene, for ethane, for methyl groups, etc. All these technologies has different advantages and drawbacks. For example, NMR is not very sensitive in comparison to the other. Its sensitivity is in the range of micromolar to molar. Then it's very suitable when we try to measure non-components. But if we want to identify unknown components, then we should record to LC-MS, direct injection MS, because the sensitivity is in the range of femtomolar, picomolar, nanomolar. Also, the different techniques has different advantages and drawbacks. For example, NMR is very suitable for water-soluble molecules. Instead of it, direct injection mass spectrometry is mainly useful for mainly hydrophobic molecules. Also, the sample volume we need is very different from one technique to the other. If we also compare sample preparation time, runtime, data analysis, limit of detection, and number of metabolites that can be detected, direct injection mass spectrometry is a very interesting technique. We have two ways of approaching metabolomics. We have target methods. We know already what we want to measure, and then we do analysis to identify with security those components and quantify those components. These are target methods, quantitative methods. But when we do not know what is going on, we look for untargeted methods, profiling methods, chemometric methods. The approach is different. For example, in profiling untargeted methods, we do sample preparation, extraction, we do data collection, and then we use chemometric procedures to see difference, to see what is important in the treatments against control, and to monitor our interest in the differences, and then to look at these molecules and try to identify them. In quantitative target methods, we start also with sample preparation, but we already know what we want to measure, what we want to identify and quantify. We do identification and quantification, and then we do data reduction to understand the connections between all these metabolites to be able to do biological interpretation through metabolic pathways. What we try is to move from data, spectra or chromatograms to lists of components that are very clear, identified. And from the list of components, we want to move to pathways to do the biological interpretation that is very complex. And from the list of components and the metabolic pathways, we use models to detect biomarkers for specific treatments or specific health states. What is key in every step is the following. When we move from data, spectra, chromatograms to leads, we have to be very sure of the integrity of our data, the quality of our data. We have to remove noise. We have to classify properly the data, to normalize the data. to assess the real significance of the data and be sure of certain metabolite identification and also quantification. When we try to move from lists of components to pathways and to detect biomarkers, we have to be very sure of the mapping in the pathway, to be sure of the biological interpretation. We have lots of possibilities for metabolomics. All of these in the screen are possible: food and beverage tests, nutraceutical analysis, drug phenotyping. I was just selecting 4 examples in red, and I want to pose you a few examples just to see how it works. For example, medical metabolomics is a very important field today because it's possible to generate metabolic signatures of disease states or host responses, for example, to a drug or a bioactive ingredient. It's possible to obtain an holistic view of metabolism and the effects of a specific treatment on metabolism. It's also possible to accelerate assessment and diagnosis of a functional problem or a disease. It's a very accurate, cheap, rapid form of identifying disease phenotypes or the response of a host, of a patient, or people to bioactive ingredients of the drugs. It's also possible to monitor gene-environment interactions. And it's also possible to track the effects of a drug, a bioactive ingredient, or surgery. For example, in the field of metabolomics and drug toxicology, we have here an example of the different metabolic response of a group of people, that is the control group, and people exposed to different analgesic drugs. Then we have a different trace of responses that can be easily detected, the components that can be different between treatments by chemometric techniques like a principal component analysis. Also, we can use functional magnetic resonance to identify in a certain organ, for example, the brain, what kind of metabolites are produced, or even the effect of certain bioactive ingredients or metabolites that we enter into the body in the different regions of the organ, in the different regions of the brain. We can also do metabolic microarrays. For example, we can expose different people, different patients to different treatments, and we see the different response, the metabolic response of the different people. In the case of food, we can give to the people, for example, strawberries with polyphenols, and we can measure the metabolites in the gut. Then we can have metabotypes for the different people because of the different microbiota in the different people. Metabolomics is also an important field for transplants because we can use non-invasive samples like urine, blood, bile. It can be very quite organ specific. The response is very fast, 60 seconds, just seconds, minutes, not like a gene, protein, and tissue changes that happen in minutes, hours, or days. It can also be simple to monitor patient or organ function before and after the operation. For example, in the case of chronic renal failure, there are different biomarkers. And we have lots of biomarkers for kidney failure. These biomarkers can be related to different states of the failure. For example, creatinine is related to late stage organ stress. Trimethylamino oxidase, it can be related to early stage responses. Other metabolites can be related to tissue damage, others to oxidative stress, and some others to immune response, inflammation, etc. There is a large metabolome project running on. It was started in Canada, but now it's an international project. It got started in 2005. The mandate of this huge project is to quantify both normal and abnormal ranges of metabolites in all kind of fluids, body fluids like urine, cerebrospinal fluid, plasma, white blood cells. That has to be freely available, electronically available for all public. The purpose of all this is to facilitate metabolomics, to improve identification of a disease or the status, the health status of a people, the prognosis, that is to say how it's going to evolve the disease, the prediction, to do disease monitoring, to test for new drugs or new bioactive ingredients. It's also important for the linkage between metabolome, genome, proteome, to understand system biology, and also to develop tools like software tools to understand what is so complex, metabolomic pathways. To conclude, I want to give you some clear statements. Metabolomics is increasing, rapidly becoming the new clinical chemistry, complements genomics, proteomics, histology, is so quick producing change that is easy to detect many changes after exposure to a chemical contaminant, bioactive ingredient, drug, or whatever. And that's all. If you have any questions, please do. I'm here to be useful if it's possible. Thank you.
Thank you very much, Professor Simal, for your wonderful presentation. I have here just a questions for you. Dr. Carosho is asking, what is your opinion about using metabolomics as a tool for authentication and a measure of quality control of the production processes? Talking, of course, about the food sector.
Yeah, metabolomics is also very important in food control, above all in the area of authenticity, food fraud, to detect fraudulent food products. And there are two ways of approaching this, like I showed you before. Targeted metabolomics, to go to monitor something that is clear, a biomarker of a certain process or food product, or food fingerprinting, to use raw data, just chromatograms, spectra, and to do multivariant analysis of chromatograms, spectra, to detect fingerprintings that are clear biomarkers of the authenticity of a product, or of a product that is a fraud. That are the most useful approaches.
Thank you, Professor. Thank you, Professor Simal, for your answer. So, if there are no more questions, I thank you again, Professor Jesús Simal, for your for your wonderful presentation, and also Professor Manuela Pintado. So we finished for now our 2 keynotes, and we will just start our oral communications. So we will have 6 oral communications, as I already mentioned in the beginning of this food section. So the first speaker will be Anton Soria Lopez from Spain. Good afternoon, Anton. When you want, you can start your presentation. Remind just you have about 8 minutes for your intervention. Okay.
Okay.
We also remind everyone that posters are online in our website. So you just go to the posters section and you can see them all.
Good afternoon. I am Anton Soria Lopez. I come from the University of Vigo. Before starting my presentation, I would like to say that my English level is very is low, and I have a small hearing problem. Therefore, I would like to say that there are possible questions you write in the chat, so that I can read and understand without difficulties. Thank you. I am going to talk about effect of solid liquid extraction on the lipid composition of focus vesiculosus. Introduction. Algae are rich compounds beneficial to health and have a great interest because of the many applications for food industries. Therefore, the importance of algae as a source of high value fatty acids intended for nutrition is increasing rapidly, and methods for the maximum extraction and best determination of unsaturated fatties in algae are needed. Traditionally, these lipids were extracted using solid liquid extraction methods. However, these methods present the following disadvantages. It is time consuming, needs a lot of energy, and it uses solvents which not in accordance with the current regulation. Therefore, it is necessary to develop new extraction processes to exploit the bioactive present in the marine algae. Among others, pressure liquid extraction is currently an advanced environmental friendly technique, since it offers the following benefits: short extraction time, decreased solvent consumption, decreased sample handling, and increased yield. In this study, a species and marine algae is employed, specifically Focus vesiculosus. It is a macroalga belonging to brown species, and can be found in the northwest coast of Spain. They are very frequent in Galician course. Aims of this study: 1. Analyzing the composition of lipids in focus vesiculosus. 2. Visually liquid extraction optimization for the extraction the bioactive present in the angles. Concretely, focus vesiculosus. From the nutritional point of view, insaturated fatty acids are relevant. Arachidonic acid, eicosapentaenoic acid, and oleic acid are some examples. Section of results and discussion. This table shows the lipid content and fatty acids profiles of focus vesiculosus. The lipid content obtained was 6.6%, and 10 fatty acids were detected. Oleic, palmitic, and myristic acids were the most predominant. Due to focus vesiculosus accumulate high fatty acids quantities, and the effect on the lipid composition of different visually liquid extraction conditions was investigated using this angle. This table shows the yield visually liquid extraction extracts in percentage using 3 extraction temperature: 18, 120, and 160 degrees Celsius, and 5 solvents which different dielectric constants. As expected, the yield increased with extraction temperature, reaching the maximum at 160 degrees, which ethanol watched 50-50. In the range of temperature studied, fatty acid profiles were found to be similar, showing the lipid composition is not affected by temperature. Therefore, the 120 degrees Celsius was the optimum temperature. This table, from the results shows in the table, ethanol watcher 50-50 solvent is not proper solvent to extract fatty acids from algae. Fatty acids profile were different, and fatty acids proportions depending of the solvent used. For example, ethyl acetate improve oleic, ARA, and EPA to compare to acetone and ethanol. The quantities almost the double. And the improved compounds correspond to long chain fatty acids. Therefore, they are the most solubles in non-polar solvents than the short chain fatty acids. Conclusions. Focus vesiculosus is a good candidate to exploit fatty acids for the novel food products. Pressure liquid extraction technology is currently an environmental friendly technique to exploit high quality lipids. In this case, insaturated fatty acids using ethyl acetate and 120 degrees Celsius as temperature. Thank you for your attention.
Thank you very much, Anton, for your brilliant presentation. I will just ask you to stay in line because we will proceed for the other communications, and at the end of all the communications we will see or gathering the questions for each one of you, okay? So now we will proceed with the next oral communication. It will be performed by Filipa Fernandes from CIMO IPB, Portugal. So Filipa, when you wish, you can start.
Good afternoon. The work I have present today is tools to develop dairy ingredients, bioactive and preservative purpose. The cheese is a widely consumed, easily digestible and well-tolerated dairy product. It is a rich source of calcium and saturated fatty acids that can contribute to high low-density lipoprotein cholesterol, a well-defined risk factor for cardiovascular disease. Zoosterols, phytosterols, and mycosterols are sterols chemical homologous to cholesterol. These molecules interfere with the micellar solubilization of cholesterol in the intestine and reduce the efficiency of cholesterol absorption. In relation to mycosterols, the ergosterol is the most abundant sterol in these organisms. The ergosterols were reported different bioactivity. So, the objective of this work is incorporation of agaricus bisporus extract, which contains mycosterols and pure ergosterol in cheap cottage cheese, in order to develop a functional food with hypocholesтерemic effects. The mycosterol extract were obtained by ultrasound-assisted extraction, and the cheese extract for ergosterol and cholesterol quantification by succinate extraction. For incorporation, we incorporation 40 milligrams of agaricus bisporus extract per gram of cottage cheese and 3 milligrams of pure ergosterol per gram of cottage cheese. So we get 3 different samples: cottage cheese with agaricus bisporus extract, with pure ergosterol, and without any of the select ingredients. For nutritional characterization, moisture, fat, proteins, and hash were determined. For chemical composition, fatty acids, free sugars, organic acids, and ergosterol and cholesterol were analyzed. And for physical parameters, color and texture were determined. For bioactive properties, the cytotoxicity and hypocholesтерemic activity were performed, and it was also verified the microbial load the cottage cheese. The results of nutritional characterizations are very similar between samples. The moisture is 69 grams. The most abundant macronutrient is a crude fat, and this cheese will have 180 kilocalories. The major sugar is the lactose, and 12 fatty acids were detected. The most abundant is palmitic acids. 6 organic acids were detected. The major is lactic acids. In relation to color, there was not a very intense color shift between cheese. The darkest cheese, the unincorporated with the Agaricus bisporus extract. Initial texture was the same in all cheese, but the adhesiveness decreased significantly over time, and the cohesiveness increased over time. The cholesterol content present in cheap cottage cheese runs from 27 to 29 milligrams. Concerning the incorporation of Agaricus bisporus extract and pure ergosterol, the incorporation was not 100% efficient. According to the toxicity evaluation, a subtoxic concentration of 50 micrograms per milliliter of ergosterol was selected and applied in the cells transport assay. For the cells transport assay, different samples with ergosterol and cholesterol were prepared. Regarding of cholesterol absorption, the cheese with poor ergosterol reduce cholesterol absorption by around about 21%, while cheese with Agaricus bisporus reduce absorption around about 13%. In relation to microbial load, for aerobic mesophilic, the microorganisms grow over time was constant in all cottage cheese. For enterobacteria and psychotrophic bacteria, the microorganism increase was verified in all the formulation, just like to yeast and molds. The Staphylococcus aureus grow in the old cottage cheese. In conclusions, the incorporation of 2 hypocholesterolemic agents did not cause significant change in the cottage cheese. Regarding the hypocholesterolemic activity, a strong capacity of the Agaricus bisporus extract and poor ergosterol in reducing the cholesterol absorption by the CACU2 cells. So, development of a functional dairy product with hypocholesterolemic capacity in line with the consumer and the industry needs. Thank you very much for your attention.
Thank you, Filipa. Thank you very much for your excellent presentation. So now I will introduce you the next speaker. It is Filipa Mandim, also coming from Mountain Research Center IPB from Portugal. Filipa, when you want, you can start.
Okay, good afternoon. First of all, I want to thank the organization, the opportunity to present his work that is about the phenolic composition and the bioactive properties of cardon bracts, and how does the maturation stage influence those parameters. So the planet's resources are increasingly scarce, reason why their most efficient use is gaining attention. Several studies make reference to the parameters such as the genetic background, the environmental conditions, and also the plant tissues has on the phenolic composition and consequently on the bioactive potential of the plant species. Cyanara cardunculus, commonly known as cardon, is a Mediterranean herbaceous plant with high important value as a result of its several industrial applications. It is used as in the production of paper pulp, bioenergy, and in pharmaceutics and cosmetics. Cardon has also long tradition being used as a result of these therapeutic properties. So this work has the objective to characterize the phenolic composition and the bioactive properties of cardon bracts collected at several maturation stages and at the same time valorize this part. So, cardon bracts from the variable altylish were collected in Greece at several maturation stages, and all the samples were extracted by a solid liquid extraction with a hydroethanolic mixture. Samples were collected during the growing period of 2017 and 2018. According to the BBCH scale, the principal growth stages of the samples were between 5 and 8, 9. Bract samples were collected at 8 harvest dates according to the scheme presented. For the phenolic composition, were analyzed by high-performance liquid chromatography coupled to a mass spectrometry. For the evaluation of the antimicrobial activity, were used the microdilution method and several bacteria and fungi species. For the evaluation of antiproliferative activity, we used the sulforhodamine B assay and several tumor cell lines and a non-tumor primary culture obtained from pig liver. For the evaluation of anti-inflammatory activity, was measured capacity of the extracts to inhibit the production of nitric oxide using a murine macrophage cell line. And finally, for the antioxidant activity, we used 2 in vitro assays, the lipid peroxidation and oxidative hemolysis assays. Moving on to the obtained results, were tentatively identified 12 phenolic compounds with the 3,5-O-decaffeoylquinic acid and apigenin 7-O-glucuronide, the ones in general, the majority ones. Samples at early maturation stages revealed higher content of phenolic compounds when compared with samples at late maturity. For the antioxidant activity, we verified that all the samples had capacity to inhibit the lipid peroxidation, especially the samples at early maturation stages with the lowest IC50 values. For the Oxlia assay, also all the extracts revealed the ability to inhibit the oxidative hemolysis, but in this assay were the late maturity samples that revealed the highest activity. For the cytotoxic activity, also the extracts with lowest stage of maturity presented the lowest GE50 values and therefore higher cytotoxic potential. The lung carcinoma cells and the non-tumor culture were the ones that revealed the lower susceptibility for the Bract extracts. The anti-inflammatory potential was evaluated through the capacity of the extracts to inhibit the production of the pro-inflammatory mediator nitric oxide, and was verified that almost all presented capacity to inhibit the nitric oxide, except samples C2 and C3. The sample at earliest maturation stages was the one that revealed the highest anti-inflammatory activity. Finally, for the antimicrobial activity, were used 6 bacteria and 6 fungi strains. Extracts C1 and C6 were the ones that revealed higher antibacterial potential with the lowest minimal inhibitory concentration values. And for the antifungal activity were the extracts C2 and C4 that revealed the highest potential. As a conclusion, cardon bracts were the parts of the cardon that are less used and normally are discarded as byproducts. Reason I is important to promote their valorization and proper use. According to the results, bracts collected at the earliest maturation stages revealed the highest content of polyphenols and also higher capacity to inhibit the lipid peroxidation, the tumor cells proliferation, the nitric oxide production. For other hand, extracts at late maturity revealed the highest capacity to inhibit the oxidative hemolysis. Both of the extracts presented capacity to inhibit the bacteria and fungi growth. And finally, I want to thank you all for your attention.
Thank you, Filipa. Thank you for your presentation.
Thank you.
So now we will move on. I will present you Ingrida Kraujutien. I think I don't know if I pronounced correctly your surname. She's from Lithuania.
And finally, I want to thank you all for your attention.
It's okay now.
The problem is that you have the new generation of extruded foods is very popular in the world. Onvolate and others claim that the extrusion process opens up unlimited possibilities for the creation of new high fiber foods. According to Fuller and Alice, nutritional fibers can reduce the blood glucose level by slowing down digestion and absorption of carbohydrates. The results of a study conducted by Fanindra shows a reduction in blood glucose levels has been observed with prolonged use of extruded product. To promote health, nutrition and education society, Food Technology Department of the Faculty of Technologies at Kaunas Kolegija, University of Applied Sciences, is developing a safe, innovative, high-value, functional food production. The degrees has been a recently developed product made from extruded corn. For the production of chocolate-coated dragées, extruded corn to flour dark chocolate containing 4 and 30% of sugar made from a mixture of cocoa mass, cocoa butter, and sugar have been used. A new product was produced by using the extruded grain, but the influence of this product on the level of glucose is in the capillary blood is unknown. The aim of the research to determine the influence of the dragées made from extruded product on the level of glucose in the capillary blood. The production of dragées consistent of the following stages. First, chocolate tempering, pre-coating, gumming of the extruded corn, and polishing. Chocolate tempering to temper dark chocolate sharp temperature reduction from 45 to 28 degrees of Celsius and increase of the operation temperature up to 31, 32 degrees of Celsius been applied. Pre-coating was the second stage of the dragées product. Chocolate was slowly poured onto the extruded corn into the coating machine, and the corn was covered with several layers of chocolate to make the surface smooth and the core to be completely covered. Polishing is the third stage of the dragées production was polishing. Polishing of dragées was done twice to better gloss of the surface. Research methodology. 57 volunteers were investigated, 23 non-diabetic, 34 diabetic, type 1 diabetes participants 5, second type diabetes participants 29, age 18 to 84 years. The volunteers had to fill in anonymous questions on their lifestyle. The tests were performed in the mornings. The participants were asked not to have breakfast, not to drink water in the morning, abstain from alcohol, and not to exercise intensely on the day before the test. The subject consumed 40 grams dragées. The glucose concentration in capillary blood has been measured with Contour Plus system. Composite of dragée number 1, extruded corn and bitter chocolate with 4% of sugar. Dragée number 2, extruded corn and dark chocolate with 30% of sugar. It has been observed that when the non-diabetic participants of the research were given to test dragees with bitter chocolate, after 15 minutes, the glucose level in capillary blood increased up to 0.76 millimoles per liter, followed by a gradual down the curve. After 2 hours of the consumption of the product, the capillary blood glucose concentration was the same as before eating. In participants with first type diabetes, the maximum change in capillary blood glucose was 3 millimoles per liter after 30 minutes. After the spike of sugar level, the capillary blood glucose level gradually decreased. And 2 hours after use of the dragees, no change in glucose level were observed. In patients with second type diabetes, the maximum change in capillary blood glucose was 2.2 millimoles per liter after 15 minutes. And after 30 minutes, the blood glucose level started to decrease. And after 2 hours, it was 0.7 millimoles per liter lower than before use of products. When the non-diabetic participants of the research were given to taste dragees with dark chocolate, the maximum change in capillary blood glucose was 1.3 millimoles per liter after 30 minutes, and after 2 hours of the consumption of the product, the capillary blood glucose concentration was the same as before the product. In patients with first type, the maximum change in glucose concentration was 1.75 millimoles per liter after 15 minutes, after which the glucose change curve gradually decreased, and after 2 hours, capillary blood glucose levels were the same as before consumption of the product. In patients with second type diabetes, the maximum change in capillary blood glucose is 2.5 millimoles per liter after 30 minutes, and after 2 hours, capillary blood glucose levels were the same as before consumption of the dragees. Conclusions: composition of the dragees made from extruded corn and dark chocolates does not cause spikes in blood glucose levels in either healthy and diabetic people. Therefore, it can be said that this new product is suitable of people with high blood glucose level. Thank you for your attention.
Thank you, Ingrid. Thank you very much for your presentation. Now I will present you the next speaker. It will be Jonathan Massaueda, that will speak from Brazil. Massau,
Olá.
once you can start your presentation.
Vídeo. Compartilhar a tela. Pronto.
Okay.
So, good afternoon, everyone. My name is Jonathan Massaueda. Thank you, Sandrina, for introduction. And thank you for all the scientific commission for giving me the opportunity to present this work. So my present work is natural food preservatives, application of rosemary, basil, and sage in yogurts as a viable alternative to artificial ones, using sustainable, low-cost, and efficient processes. So foods are susceptible to a lot of ways of degradation, which can be by the oxygen present in the atmosphere or microbiological factors, physical and others. And one alternative to preserve food is the use of antioxidants or antimicrobials. And the natural preservatives, for example, compounds produced by plants by the secondary metabolism, is considered compounds to defense against microorganisms, oxidizing agents, and helping the pollination process. So in this work, we used three plants: rosemary, basil, and sage. And in order to evaluate the preservative capacity of each one. In the first step, we used a fractional factorial design to the structure optimization, and the factors that were tested were time, solvent, and ultrasonic power. And then, after the optimization, we made the phenolic profile and the quantification. So for the bioactive properties, we made the antioxidant activity using the oxidant method. And then for the antibacterial and antifungal activity, we use the microdilution method. For the cytotoxicity, we used the sulforodamine B method. And for the incorporation process, first we made the yogurt and added the extracts into the yogurt maker for about 8 hours. And then when the yogurts were made, we added the fruit pulp, and then we made the following analysis. So first of all, the physical-chemical analysis, we evaluated 3 parameters: color, pH, and water activity. For our nutritional profile, we made the approximate composition and the energetic value according to the AOAC, and then the organic acids and the soluble sugars too. And lastly, we made the microbial load, taking account into microorganisms that are common in yogurts. So for the results, on the structure optimization, in the chart, you can see that the solvent was the factor that has greater influence in the extraction of rosmarinic acid, followed by time and ultrasonic power. And then we tested some ranges of time of extraction and temperature. And after the optimization, we got the time of 1 minute, the temperature of 75 degrees Celsius, and the ultrasonic power of 375 watts. After that conditions were established, we made the instructions for the incorporation. So for the bioactive properties, for the antioxidant activity, the rosemary presented the best results, followed by sage and finally basil. For antimicrobial activity, rosemary and sage showed the best results, followed by basil. And antifungal activity, rosemary showed the best results, followed by sage and then basil. For cytotoxicity, none of the 3 extracts tested presented toxicity over the limit of concentration tested. So for the physical-chemical analysis, overall, in general, the storage time had much more influence than the preservative types. And for nutritional profile, the same thing occurred, that the storage time had much more influence. So for the organic acids, we see increase in the lactic acid over the storage time, and that is justified by the presence of lactic bacteria over the time in the yogurts. And for the soluble sugars, we can see justified for the lactic bacteria too, the decrease of the lactose being consumed over the time. And lastly, for the microbial load, for aerobic mesophilic, there was a slightly decrease over the time, but not significant, but not statistically significant. And for lactobacteria, we saw a slight increase over the time. For coliforms and molds and yeasts, there was no growth over the 14 days. So in conclusion, for the structure optimization, the most influent parameter was the solvent and the time after the ultrasonic power. For the bioactive properties, rosemary in general presented the best results, followed by sage and then basil. And none of the 3 extracts showed hepatotoxicity. For the physical-chemical analysis and nutritional profile, we saw that the storage time had much more influence than the preservative type. And a good positive point in this work is that the 3 plant extracts showed similar behavior to potassium sorbate. That is a synthetic additive used in yogurts. And finally, for the yogurts, I studied fundamental about this food matrix, is the presence of the lactic bacteria in yogurts. And two things that must be considered when you search for a new preservative in yogurts, that is, the preservative must preserve the food, and then he must ensure that they will have lactic bacteria over the time. And those two things were confirmed on this work, seeing the lactic acid on the organic acids, the lactose on the soluble sugars profile, and the microbial load psychotrophic lactic acid bacteria. So thank you for all the members that helped on this work and all the organizations that helped with the financial support.
Thank you, Jonathan. Thank you for your excellent presentation. So let's move for our last oral communication that it will be performed by Ricardo Ferreira from Portugal also. So Ricardo, when you want, you can start your presentation.
Hello, can anybody hear me?
Yes.
Yeah, okay, thanks.
Okay.
Yeah, okay, thanks. Hello, good afternoon. My name is Ricardo, and I'm going to be presenting to you the work that I've been developing during the first part of my PhD, that is entitled The Effect of High Pressure Processing and Thermal Pasteurization on the Microbial and Physico-Chemical Properties of 3 varieties of Opuntia ficus indica. Opuntia ficus indica, or prickly pear in English, is considered an important food resource through the Mediterranean basin, mainly in Italy and North Africa, and the fruit itself is considered to be rich in nutrients and bioactive compounds, as you can see from the table on the left, for example, it possesses 3.6% of total dietary fiber, as well as some minerals, for example, like magnesium, phosphorus, and potassium. Prickly pear is as well known for its health benefits that include, for example, its antioxidant capacity. However, despite this richness in nutrients and health benefits, almost no commercial available products of prickly pear are available in most of Europe. So the idea behind this project was trying to integrate Opuntia ficus indica in the European daily life through the production of high-valued products from prickly pear. And we thought that, for example, prickly pear beverages that are perceived as healthy, tasty, and refreshing could be an opportunity, an attractive opportunity among the fruit manufactured products. And that's why in this part of my PhD, I was developing prickly pear beverage that I will be showing to you the results a few minutes later. The fruit itself, prickly pear, possesses a pH superior to 4.5, so the nectar produced from prickly pear is considerable a perishable drink, and because of that it needs further processing. And the idea behind this project was trying to compare two different types of pasteurization, the thermal pasteurization and the high pressure pasteurization, in order to evaluate its effects on the shelf life, the value of the product, and the organoleptic effect. So we use for thermal pasteurization 71 degrees and 30 seconds, that is the time and temperature used for industrial purposes for the production of high quality premium juices. And we use for high pressure pasteurization 500 megapascal for 10 minutes. In order to evaluate the impact of the pasteurization methods, the two that I just told you about, some physical chemical analysis were made. We analyzed the pH, the treatable acidity, cloudiness, browning, total soluble solids, and the reducing sugar content. As I told you in the beginning of my presentation, I analyzed and I studied three varieties of Opuntia ficus indica, or prickly pear, and I'm going to be presenting to you the results of the three of them. But in order to make it easier, the discussion, and easy to understand, I will be focusing only on the orange nectar, because the results are very similar for the three varieties that I studied. Regarding then the microbial load, as you can see from the graphic in the middle, when high pressure processing and thermal pasteurization are applied to Enterobacteriaceae represented in red and yeast and mold represented in green, and you cannot see some of the green lines because they are behind the Enterobacteriaceae line on the bottom, you can see that when applied high pressure processing and thermal pasteurization to those microorganisms, their microbial load goes below the detection limit line. And so that's why they are represented in 0. So regarding the microbial load and the increase in shelf life for the products, we'll only need to use the TAP microorganisms to discuss it. So you can see here for the raw nectar without pasteurization that the shelf life is around 8 days, because in this dotted line is the threshold of 6.48 where the food is considered spoiled. And for the thermal pasteurization, you can see that is around 30 days. And for high pressure processing, it's about 60 days. Regarding the physical chemical properties, you can see that for the orange nectar, there is a small decrease in pH during the duration of experience. And regarding the tritratable acidity, you can see that for the orange nectar, there is an increase in the tritratable acidity due, for example, to the fermentation process that is occurring. And you can say that the fermentation is occurring because you can see that the microbial load is increasing. So the microorganisms are producing some organic acids that can influence the tritratable acidity of my nectars. Regarding the bricks, cloudiness and browning, you can see that through the duration of experience, the cloudiness maintains more or less similar during the 45 days. For the bricks degree, you can see that there are a slight decrease in the bricks or total solid solids during the duration of experience, and you can see a slight increase in browning during the 45 days of the experience. You can say that through the analysis of those two methods, that the sugar available is decreasing, for example, mainly to the Maillard reactions that are occurring between the proteins and the amino acids and sugars of my samples. Regarding the reducing sugar content analyzed by the NS method, you can see that the variation of the concentration of reducing sugar varies only slightly. And when you can see a slight increase in sugar contents, maybe due to the liberation of sugar from degrading cells provoked, for example, from some of the organic acids resulting from the microbial organism's action. Regarding the conclusions, you can see and you can say that the treatments of thermal pasteurization and high pressure processing allow the Opuntia nectars to increase their shelf life in approximately 25 days for thermal pasteurization and 40 days for high pressure processing. Regarding the physical chemical properties, you can say that they were maintained within acceptable ranges between 5 and 8 days for the non-pasteurized samples, up to 30 to 45 days for the thermal pasteurization samples, and up to 45 to 60 days for the ones treated using high pressure processing. So in conclusion, you can say that both the thermal pasteurization and high pressure processing allowed to maintain the microbial and physical chemical properties within acceptable ranges to the duration of the experience. However, high pressure processing samples had a higher increase in shelf life when maintaining the similar organoleptic effects as thermal pasteurization. Thank you very much for your attention.
Thank you. Thank you, Ricardo, for your so elucidative and clarifying presentation. So now we will have time, just a few minutes for some questions. We have here already some questions for Filipa Mandim. Teresa Brás is asking if you correlate the biological activities that you obtained with the phenolic compounds you identified in the extract.
So the correlation is being made. We have preliminary results that indicate a better correlation, especially with flavonoids, but at the moment we don't have the final results.
Okay, we have another question for you that is from Fatima Duarte. Fatima Duarte is asking, what was the flowering stage of the beginning of the collection time, with or without flowers?
That part of the cultivation and harvest of the sample is made by one of our partners, Professor Spiridon Petropoulos in Greece. And I know that in the beginning of the samples collection, no flowers is in the sample, but that kind of information is better to obtain it from Professor Spiridon, and then I can send an email with the final information.
Okay, so Teresa Braz, if you have any doubts about this issue, you can send an email and we will address it to Filipa so she can answer if you have any more doubts about this subject. So thank you, Filipa. We have now a questions for Filipa Fernandes that is made by Joana Rolo. And Joana Rolo says, can you elaborate on the safety of using these ingredients in food products? Thank you, and keep up with the good work.
Well, you analyzed the toxicity of the extract and they presented no toxicity for normal cells, but more assays are needed to be sure about that.
Okay, so more. In conclusion, you need to perform more assays to be sure about this application as food ingredients.
Yes.
Okay, so I think we have no more questions. I thank you all the participants and all the speakers of these oral communications for the food section. Now we will have a mini break and then we will start with a pitch section that will be moderated by my colleague, Dr. Márcio Carocho.
Hello, good afternoon. Welcome back to our conference. We will be starting the pitch presentations, which will be followed by the final keynote session of the day. So I would just like to remember everyone that you can post all the questions you have on the YouTube streaming, which is in the IPB's web YouTube page. Please post your questions. And for the people asking where they can find the posters are all displayed in the website of the conference, which is hosted in the Escola Superior Agraria's webpage. So please go there and you will find the conference posters. So without further ado, we will go on to the first pitch presentation, which will be given by Andrea Quaresma, which is a member of the Mountain Research Center. At the end of all the pitch presentations, we will have a short moment of discussion. I would ask everyone that will be presenting to keep their time to the strict necessary. And Andrea, please, you may start.
Good afternoon. My name is Andrea Quaresma, and my work consists on the identification of the origin of collected pollen. This is one of the pea products that have long been used in humans' diet and which is recognized as beneficial for human health. The data that I'm presenting today were obtained in the framework of Insignia, an European citizen scientist project. 108 pollen samples were collected from pollen traps set up in front of beehives from 10 European countries in an attempt to capture a wide botanical diversity. The samples were then sent for our lab in SIM for metabarcoding analysis. But before any analysis, the samples were homogenized in order to obtain homogeneous subsamples and split into two sets. One set was sent to the Institute of Apiculture in Germany to be analyzed by palynological experts, and the other set was analyzed for metabarcoding in collaboration with CBU. The goal of these two analyses was to assess the reliability of metabarcoding before its implementation on Insignia project. To that end, relative abundance at family level were calculated for both methods and compared. Overall, palynology and DNA metabarcoding show a good correlation, with GRIS showing the worst results. Some outliers can be spotted, which are being reanalyzed to make sure it wasn't a sequence artifact. Furthermore, the 4 most abundant families were found for each country, and Rosaceae, Fabaceae, Asteraceae, and Brassicaceae are the preferred plants by bees. From 10 countries, 11 families were found as most abundant, suggesting that bees are foraging in a wide range of plant taxa. Although these preliminary results suggest that ITS2 metabarcoding is a reliable alternative to the classical palynology, we are Sanger sequencing bee plants to enrich the ITS2 database in the hopes of improving the taxonomic classification. The second year of insignia is underway and the samples collected are being prepared and analyzed. I would like to thank the Insignia Consortium, CIMO, the Portuguese beekeepers that providing us pollen, and the CBU team. Thank you all for listening.
Thank you very much, Andrea, for the nice presentation, for keeping to the time. So we will go to the next presenter, which is Bianca Rodrigues de Albuquerque, who comes from Brazil. Bianca, whenever you want, please.
Hello, everyone. I'm Bianca. I told you will share with you part of my work, flavonoid composition in vitro antiproliferative activity of the hydroethanolic extract of Garcinia mangostana pericarp. Garcinia mangostana, also known as mangosteen, is a tropical fruit native from South Asia, but also found in other tropical countries, such as Brazil and Colombia. This fruit is very appreciated for the pleasant taste of this pulp, but the consumption and the process of the mangosteen fruit can generate a high amount of bioresidues, signs that more than 6% of this fruit correspond to an edible dark purple pericarp. So, in order to propose a valorization of this bioresidue, this work aimed to evaluate part of the chemical composition of the mangosteen pericarp, namely the flavonoid compounds, including anthocyanins, and evaluate the antiproliferative activity of its hydroethanolic extract. For it, the extract was obtained for maceration with ethanol in the water, and the flavonoid compounds were identified and quantified by HPLC system with mass spectrometry detector, and the antiproliferative activities was evaluated by superrhodomine BSA using 4 human thermocell lines. So, as a result, we can see that mangosteen pericarp extract shows a total of 11 flavonoid compounds, begin of them 9 no-anthocyanin flavonoids and 2 anthocyanins, and procyanidin compounds were the most abundant compounds flavonoids found in this bioresidue. In total, the extract showed 53 milligrams of no-anthocyanin flavonoids and 3.66 milligrams of anthocyanins per gram of the dry extract. And regarding the antiproliferative activity, we can see that mangosteen pericarp extract has a high antiproliferative activity, signs that low concentrations of the extract were necessary to inhibit 50% of the growth of all tumor cell lines evaluated. So you can conclude that mangosteen pericarp could be an interesting source of the bioactivity compounds, and after more studies, these compounds could be applied in several industrial fields, including pharmaceuticals and food industries, for the production of the nutraceuticals and the functional foods. Thank you very much.
Thank you, Bianca. Once again, very strict on time. And once again, I will try and tell everyone once again that we will have the questions at the end. So now we will go on to our good friend Francesco Di Gioia, who is Italian, but is working now at Pennsylvania State University. So Francesco, please.
Thank you, Marshall.
thanks for the invitation to present this with my colleagues, Spiridon Petropoulos and Erin Roscoff. We prepared a very short presentation to talk about tailoring food crops to address specific dietary needs. And we want to highlight the case of microgreens, which are considered nutrient-dense immature greens harvested after a very short crop cycle at the cotyledon stage. And the idea that we want to present is that there is the opportunity to basically tailor the mineral profile of microgreens using different agronomic biofortification techniques. And here I would like to present what we did in a couple of studies, one in which we were looking at enriching 3 different species of brassica microgreens with iron and zinc. And this is the experimental setup replicated 3 times. And we used basically zinc sulfate as a source of fertilizer for the zinc. And with this experiment, we showed that it's possible to increase from 75 to up to almost 3 times the content of zinc compared to the standard greens that were not fertilized with zinc. And similar results were obtained using iron sulfate. And we see in this case that the response is really species dependent. So the selection of the species that are more suitable for this purpose, for enriching the content of iron or zinc, is very important. Beside enriching nutrients, we also have the opportunity to reduce the content of specific minerals. And here I'm reporting the case of low potassium microgreens that were studied as a potential opportunity to address the issues of patients affected by hyperkalemia, which is basically toxicity caused by an excess of potassium in patients that are affected by chronic kidney disease. And this was again the experimental setup, and we used 3 levels of potassium: the standard rate, which is 100% of the reference level, and then 25% of that level and no potassium. And this was the outcome. And we showed that it's possible to reduce from 50 to 80% the potassium content. And this was obtained without reduction of yield. And also there was an effect a little bit on the shoot size, but also we saw enhanced total phenolic content and antioxidant compounds. With this, I would like to thank our sources of funding and the people that help us with this project. And thank you again.
Thank you very much, Francesco, for that nice presentation on microgreens. So we will go on to our 4th presentation pitch. It will be given by Isabel Ribeiro, which is also a Portuguese researcher. Isabel, whenever you want, please.
Okay, so good afternoon, everyone. My presentation will be on exploring cranberry extract ketones and fumes towards the improvement of antimicrobial food packaging. Okay, it is a fact that foodborne diseases are a problem worldwide, and also that there is an emergent need to reduce plastic consumption and find more sustainable food packaging. So new strategies to prevent food waste and deterioration and the food packaging system are a need. The aim of this work was the development of ketones films incorporated with cranberry extracts to produce new biodegradable, eco-friendly films with enhanced antioxidant, antimicrobial, and anti-biofilm properties. Before films development, we had to characterize the cranberry extract activity and composition. So we observed that the films had antimicrobial activity towards the tested bacteria and antioxidant activity. Different phenolic compounds were identified through LC-MS/MS analysis, and also it was possible to detect A-type procyanidin compound, which is an important compound regarding its antibiofilm activity. Knowing that our extract was suitable, we proceeded with the production of films, and we produced 2 chitosan films, one added of PEG as plasticizer, and the other added of PEG and glycerol as plasticizers. Films produced detain a good light protection, especially under UV light. Water contact angle measurements we observed a low contact angle, which can be an advantage considering that several bacteria tend to adhere more to hydrophobic surfaces. Water vapor permeation and oxygen permeation were suitable. And regarding the mechanical properties of films, films added of PEG presented a higher extension percentage. Regarding the film's antibiofilm activity, we had a very good antibiofilm activity with this cranberry extract films. No SCRUs was detected on the surface, and regarding E. coli, few bacteria were observed, and some of them were dead, which are here stained in red with the Propidium iodide stain. As a conclusion, we can say that it was possible to identify phenolic and other compounds responsible for the antimicrobial and antioxidant activity of these films. The properties evaluated assured film suitability for food quality maintenance. Films also showed antioxidant and antimicrobial activity, and a significantly reduction on E. coli and SCRUs biofilms was an outstanding outcome. Finally, I would like to thank my colleagues from the Faculty of Pharmacy and my other co-workers from the Nova University, and also the audience for their attention. Thank you.
Thank you very much, Isabel, for the nice presentation. So we will go to the second to last presentation, the pitch presentation, which is another researcher from the house, José Pinella. José, you're ready, please.
Good afternoon, everyone. I will present some results of an extensive study that aims the valorization of Solanaceae crop byproducts as a source of bioactive ingredients. Tomato is highly consumed worldwide, and its annual production generates a considerable amount of plant byproducts. Although tomatoes are well known for their composition in nutrients and bioactive compounds, little information is available in literature regarding tomato leaves. Therefore, considering the massive production of these biomass and the current trends of circularity and sustainable development, this study was performed to evaluate the phenolic composition and the bioactive properties of tomato leaves provided by the Portuguese Gen Bank located in Braga, Portugal. So the samples consisting of pruning materials and end-of-cycle plants were used to prepare hydroethanolic extracts, which were used to characterize the phenolic composition by HPLC-dead ECMS and used to evaluate antioxidant activity by the DPPH and reducing power assays, the anti-hemolytic activity using sheep erythrocytes, and the antimicrobial activity was tested against foodborne microorganisms by the serial microdilution method and the colorimetric assay. The chromatographic analysis allow identifying phenolic acids and flavonoids, as we can see in the bar chart, with prevalence of cysteine 3O rutinoside or rutin. We also found that the pruning material had a higher polyphenols content than the end-of-cycle plants. The leaf extracts show antioxidant activity with a better performance than the corresponding tomato fruits previously characterized by us. Some pruning materials were also effective in protecting the erythrocytes from the oxidative hemolysis, with results close to that of Trolox, the positive control. And some extracts also had the ability to inhibit and kill some bacteria more effectively than the antibiotic ampicillin. Therefore, we conclude that table tomato crop byproducts can be recycled to produce routine-rich bioactive extracts for possible use in the agri-food sector as natural preservatives. Finally, I want to thank my work colleagues, the supporting entities, the conference organizers, and everyone for listening. Thank you.
Thank you very much, José, for the nice presentation. And now we will go to the final presenter of the pitch sessions. I will try and pronounce your name correctly. So it's Shemanur Ertosun, from Turkey. Please.
Can you hear me well?
Perfectly.
Okay. Good afternoon, ladies and gentlemen. I will be presenting you the nutritional, technological, and sensory attributes of bread enriched with bee pollen and bee bread. When bees visit the plants, they collect the plant pollens and they mix with their secretion enzymes and the nectar. And this mixture agglutinate, and this is how bees upgrade the basic plant pollen to bee pollen. And some of these bee pollen kept in the hives, and bees cover on top of it. And this is this closed environment lead to anaerobic lactic acid fermentation. After that fermentation process, we have new product called bee bread. But how did we use these products? We basically substitute the total flour amount with these two bee products separately. We prepared 3 different ratios of enriched breads, and along with them, we also prepared conventional bread in order to compare in terms of nutrition, phenolics and flavonoids, antioxidants, and bread properties. When it comes to nutritional analysis, we are seeing that when we compare with the conventional bread, there's an increase in terms of protein, fibers, and energy, and this increase quite promising. When it comes to specific volume, which is really important for the consumer's choice, there's not much of a negative impact of our bee products over the conventional bread. And when it comes to the color analysis, the more we increase the ratio, the color change is more visible. And when it comes to total phenolics and flavonoids, also with the antioxidant capacity, we are seeing and observing the same pattern is followed, which means that when we increase the ratio, we are also increasing the antioxidant capacity of our enriched bread, and the conventional bread has the lowest antioxidant capacity. And for the texture profile, it's really important for the consumer's choice in the market. There's not much of a followed pattern in this texture profile. We can say that there's not much of a negative impact over samples, over bee products, over conventional breads. And finally, for the sensory evaluation, we tested with 15 participants, and they more likely to prefer the bee bread over control and also bee pollen. But for both of the samples, our participants more likely to prefer the enriched breads when they compared with the conventional bread. Thank you for your time.
Thank you very much, Shemanur. So we are running a bit late, so I think we've got time for a couple of questions before we go on to the keynote preferred by Luis. So I've got a question here for the first presenter, for Andrea. I think she's still there. Do you think the metabar coding can be used as a complementary tool, or is it essential to distinguish the origin of pollen?
Metabar coding is now being optimized to replace completely palynology, because palynology needs a lot of expertise, and with metabar coding, we can also add a little bit deeper of taxonomic classification and go to the species. So we want to replace palynology.
Thank you very much. for Francesco. Francesco, do you think what would be the biggest difference between this reduction of potassium between doing it in microgreens or in normal greens? Is there a difference in their the way of doing
Yes, so that's a good question. There are two reasons at least to consider microgreens instead of standard vegetable. One is the fact that because of the short cycle, we can really use no potassium and still have something good to eat. The other component that is important is that microgreens are considered nutrient dense and are rich of vitamins. And the people affected by this issue normally have to boil vegetable to eat them. And then they lose all the vitamins. So this will be a very good way to still have a taste of vegetable without renouncing to vitamins.
Exactly, exactly. Thank you very much, Francesco. I have a question from my colleague here, Dr. Sandrina Heleno. She's asking if you, Isabel, sorry, I think I said Isabel. So if you analyze the stability of these biofilms over time, or was it just stopped in time?
We didn't observe through time. We had a 24 hours experiment, give 24 hours for the biofilm production. And after that time, we analyzed the produced biofilm on samples.
Thank you. Thank you very much, Isabel.
Okay.
So now I think we can go on to the keynotes, the final keynotes of the day, which will be made by Dr. Luis Angel Fernádez, who works at MAN, the company MAN, and Luis is a biochemist with a post-degree in food science from the University of Buenos Aires. His doctoral thesis relates to allulose as a rare sugar very low in calories to replace saccharose in jams. He studied the technological aspects, sensory, biological response in vivo. Fernandez has more than 35 years of professional experience in the food ingredients industry. He's worked in Tate & Lyle, Cargill, Danisco, Rodia, DuPont, and Sanofi. He lived and worked in Argentina, France, Belgium, and the United States, so he's a citizen of the world. Luis was elected Fellow of the Institute of Food Technologies in 2009, and he is also Fellow of the IAUFOST, the International Academy of Food Science and Technology, in 2010, since 2010. Currently, Luis is the Vice President of Strategic R&D for MAN since 2017. He is based in his headquarters in Le Bar-sur-Loup. It's French, I'm sorry if it's not correctly pronounced. And he is responsible of the group innovation for sweet and savory categories and strategic research partnership. Today, Luis will be talking to us about, I'm so sorry, protein transition, plant protein off-notes, myth or reality. Luis, thank you very much for accepting our invitation. It's a pleasure to have you here, and it's nice to see you once again. The floor is yours. Thank you very much.
Thank you, Marcio. And it's true that we get to know together in a virtual congress that was organized by the Argentinian university. And we get very familiar, so it's very nice to be introduced by someone who is very familiar to me, because this is a new world. We get new friends through the virtual connection right now.
Thank you very much, Luis. Thank you very much.
So let me share the presentation. There is seen by everyone?
Yes, perfectly.
Okay, so my topic, as Marcio said, is the protein transition. And what does it mean, protein transition? Is the transition from animal source to more sustainable and animal-friendly, plant-based or biofermented protein in a new world that it is considered that will not be completely becoming vegetarian or vegan, is introducing much more vegetable protein and more sustainable protein at the current time. Everybody knows that we expect to have a growing population with 10 billion in 2050, and then the need to have available and sustainable protein source is critically important. And that is the topic that we'll discuss today. So it's really introducing much more. I am not personally vegetarian, but I like to take some days meat-free or animal-free. And that is the key topic. Why or how we can really enhance the use of this alternative protein. And it's not a European issue on a European target or challenge. It's all over the world. I know that this fantastic Congress is organized with many different participants from different parts of the world, and everybody hear about this transition from animal to sustainable one. So very quickly, I will introduce MAN, my affiliation, where I am working today. Then we will discuss the protein transition and the key challenge on the off-note myth or reality, and the simple labeling and the conclusion. Are we still having half an hour, Marcio, for the presentation, including the question?
Yes, Luis.
Okay.
Go ahead.
Okay. All right. So very briefly about MAN. MAN is a French company in Bar-sur-Loup, as Marcio said, is the property of the MAN family. So you see here the fourth generation on the left side, Jean MAN, who is the CEO and is a chemist from MIT, is someone that is a pleasure to talk about molecules, flavors, reaction, and food in a way that science comes first and innovation, and not talking about return on investment as traditionally or typically the CEO are doing. On the right side is his brother, Michel Mann, who is also a chemist and is the president in America for MAN. And then to the right is Samantha Mann, who is the fifth generation from the Mann family, taken now the leadership. She is the leader in Europe, EMEA, and is bringing a lot of new space on talent development and the more modern way to approach the whole organization, keeping the tradition that has been always in the company on the naturality, innovation as the key focus. You see here in the right side, the evolution of turnover. So today, currently, is about 1,400 million euros, or what normally was a 1.4 billion. And that has been made through organic growth and making right decision on investment, especially in the international space. The total investment on R&D, that is our core focus today, is 8.3% of the total revenue, that it is around 150 million euros every year invested in R&D. We are having the fifth position in the global flavors and fragrance industry today. And then the place where I am is in the strategic development R&D. So we are focused on three major platforms: health and wellness, natural and sustainability, and flavor performance. As an example of project, protein transition is one important program that we are really focused today in a global space. My location is here in France, but we have another team as well connected in Singapore and the United States. And other important project that we are handling is in the health and wellness for sugar reduction. How can the flavor industry reply to this challenge and create this sweet modulation that is able to compensate in the best way the sugar kind of profile in the reduced sugar product. There are other important activities in the natural and sustainability for raw materials, new raw materials, natural raw material, and way to extract the active component on the aromatic side. On the left is more on the categories of 50 sites close to the market and the customers, and on the right side, the corporate research work with us on the development of solution. Our solution will go to the categories for the market. So the extraction has been from the very beginning. This year we are celebrating the 150th anniversary. So it's a great achievement for the company, and extraction has been from day one, then organic chemistry, encapsulation, and biotechnology. So the protein transition topic, let's start with a view of the consumer. This is consumer perception. So it's a M2P is man proprietary panel system that we have in place to evaluate what consumer perceive about a target topic. In this case, we had 2,338 interviews that has been made with two questions. What is your perception in terms of benefit for protein from animal, and what is your perception of the benefit from protein, vegetable protein? So what you see here on the circle and the stars are the significant difference. So what this consumer that are based in the UK, in France, and Germany, they recognize that animal protein provide energy and more than the vegetable one, and then is essential for the body and also help increase the muscle. So this is the perception. And then on the vegetable one are easy to digest, good for the heart health, also reduce the sign of aging, aid to weight loss, and also to improve the blood sugar levels. Why is important to recognize what is the perception from consumer? Because these alternative protein products that are coming to the market, they will be perceived with this bias from consumers, and it's important that the communication clarify. As you can recognize, scientific audience that we have here in this forum, many of these statements are not exclusive from one source of protein or animal or vegetable. So that is part of the communication plan with consumer. No? And then when I say that the protein transition is happening everywhere, you might recognize this wording that you see there: plant-based, alternative protein, vegan, hybrid, that combine animal and vegetable as well, dairy alternative, meat replacer, vegetarian, flexitarian. And this is all is related to three major consumer trends. One of them is what we call holistic wellness. And this is not only the physical wellness, is also the spiritual and the emotional, the right balance that the individual expects to have. And then meaningful choices is related to the sustainability decision, good for the planet, not only for me, but also good for others. And the third one is experience life, is the decision that you are taking in the food that you buy just to have a indulgent experience and enjoy the food. So these are the three motivations that we see. And the objective, as it is indicated here, is to achieve the same or better taste for a vegetable-based than the animal-based product. And it is possible. So the key industrial challenge is first the finished product quality. So consumer will not sacrifice the taste, texture, stability, and appearance of the food because of the sustainability or because they are animal-free and so on. So the quality has to be equal or better than the reference. The nutritional value, also important. The protein is the major macromolecule that we have in the body. So we have in our muscle, we have in many functional protein enzymes in our body. And as we know, we cannot produce all the amino acid. So we need the essential amino acid from the diet. So the PDCAS, protein digestibility corrected amino acid score, or the DIAS, that is digestible indispensable amino acid score, are very important to make sure that this new alternative protein provide this amino acid. Then, as it was mentioned by the previous speaker, Jose Pinela, who talk about polyphenol. So polyphenol are coming from vegetable source. So this is a plus over animal food, and also the fibers. But also we have to pay attention all the anti-nutritional factors that need to be under control in the vegetable product. Sustainability and animal welfare are the key benefits that these new proteins are providing. And the labeling need to be clear and simple, and we'll discuss a bit about that. And the cost is also important. I put open innovation because all these 5 challenges that the industry is facing, the best way to approach is to have multiple players that are working together, from the protein producer, flavor producing, equipment producer, that can really provide, and science, academic, that can be all connected to deliver the best solution. So I listed here 9 products, that is, as I put here, listed by myself, so just for one reason. One is soy and wheat are the most traditional vegetable protein that we have industrially in the market. So today, soy and wheat has the optimal use of the byproduct and the protein as well. So by far is the quality of soy protein in terms of PDCAS and so on. Also, the flavor has been quite well optimized, but people are expecting more. Soy has been in the market already for a long term, and then pea and fava bean are coming as the new players. So also very sustainable protein with a very good taste and PDCAS, and they are more and more present in the market. But still, the total equilibrium of the byproduct is something that needs to be further developed. So soy, wheat, pea, fava bean, you have the protein that is the key point of discussion today, but there is the starch, the fiber, the oil that has to be fully valorized as well. Rubisco is the protein extracted from the green part of the vegetable. So I take again the example of Jose Pinela on the leaf from tomato for the polyphenol. Rubisco can be, as an example, the leaves, the green leaves of sugar beet that is today not used. So you take the sugar beet for the production of sugar, or to eat the tubercle, but the green leaf was not used until now, and now there is an industrial production of protein from these sugar beet leaves, so the green part, that is one of the richest protein in the planet, and high PDCAS, and very good as well functionality, solubility, and can be applied in a way that taste is very good. So that is very important as well to take in consideration. It's a company in the Netherlands that is producing rapeseed and corn. I put with the same color because these are the all knows that everybody knew from many years, these 2 products, but not particularly for protein for human consumption. There is also Rubisco and rapeseed or colza, the same name, has to go to a process of novel food. It has been approved, and they are today coming to the market with available protein as well. Mycoprotein, yeast, and single cell, this is an extremely sustainable way to produce because it's through a biofermenter that you can generate high quality protein in terms of PDCAS and functionality. Still a challenge on the labeling because mycoprotein is less familiar for the consumer than a pea protein. So there is a lot of communication that need to happen. Yeast protein is more familiar for consumer, and single cell still also some communication need to happen. Single cells, they can be bacteria as well that are able to ferment and to produce protein. And then almond, cashew, hazelnut, coconut, these are protein that can be in a minor amount today, but keep growing because it's good for the taste, and maybe it's not the same level of protein, not to as a protein source, but can be to produce a vegetable food that tastes good and maybe don't have the same level of protein or quality of PDCAS. So the off note is, the question is reality of meat. As you can imagine, it's important to take in consideration the new alternative protein. So this new alternative protein, each of them will come with their own type of taste. It's normal. They are having different crops, different origin, and it's important to recognize what kind of off note might be affecting to the total taste. And also some of the flavor that are added to the product can be bound by the protein matrix as well. So these two concepts are very important to understand. And then for the off note, one value that the flavor houses have today is to understand, to identify, and to measure this particular off note. Like you see here, cardboard, beanie, green, bitter, astringent. So to have the right standards and the right panel that can identify, and then in the product that you develop, they can measure the quantity descriptor analysis and provide the spider graph to see if it is acceptable, the quality on taste. And then understanding as well the science on this flavor binding is critically important too. So there are reversible bounds, or they are covalent, irreversible, oxidation, and so on. So this understanding will help to prevent and to modify this for the benefit of the flavor in the matrix. So the life cycle of protein from nature to fork, the key starting point is the raw material. I was talking about pea, faba bean, soy, but this is the name of the crop. The quality of the genetic of that particular crop is also very important to define upfront. Today, there are molecular breeding, different way to select the right genetic of the grain, the seed that will be used to produce these crops. And that is a very important point, because if you have the right choice on the genetic of the crop, that will be much easier to have high quality product. And then you can have a flour that will be the simple ingredient one, only by physical process or just an extract from the bean. Or you can go a little bit further to concentrate or to isolate the protein and separate the fibers and the starch. And then you can also do some processing to get texturized protein, and by extrusion, wet or dry, or fermentation. And finally, you produce the final protein transition food that can be introducing other raw material, and also flavor will be used in this part of the final processing. But if you do the whole selection right, the need to have masking is less critical than having material that are not well selected. So when you look at from this flavor house perspective, typically you will recognize that one action is to add more flavor to mass. So you see some burger analog in the market that is quite spicy and hot spicy. Is a way of put a lot of salt as well, or a lot of sugar to mass. So that's not the right strategy, because that is not pleasant for the consumer. But if you go to the science and you identify the molecules that are responsible for this off note, for example, this 1-octane-3-ol, the other activity value, the higher will be. That means that the threshold to detect the molecule is very low. So you will have, with just ppb or ppm, you will have this mushroom, earthy off notes that you don't want to have. And then you need to understand as well the repartition value. So this more than one means that it's more oil soluble than water soluble, and the vapor pressure, the smaller it is, less volatile will be. The trimethylamine has a high vapor pressure. That means that it's very volatile. This kind of molecule that is fishy, seafood, you don't want to have in the final product. It's better if you can remove before having the final product. So you can have a kind of flash pasteurization and be removed during the production of the finished product. You can use also encapsulated flavor that will be released during the chewy of the final product, and that is a way to protect this flavor as well. And you can also use what is today called artificial intelligence and some algorithm to identify what are these molecules that you want to mask and make the support with augmented intelligence and get the right combination of masking. And then some of the texturized product can be a stressing condition assisted flavor that you can incorporate in the texturized material. So when you have, as an example, soy beverage, you need to first to question what off-note do you want to mask, because sometimes it's soy, pure soy, but can be also a combination of soy and pea and fava and canola and other type of protein. So basically, what are the off-note that you want to mask? And then you can put in place all this algorithm to identify the combination of the masking flavor that has to be a natural flavor that you incorporate. In some time can be 16 molecules, natural molecules, or can be 3 or 4. So the system will tell you what is the best combination that finally will remove the off-note that you want to hide. It will be reduced to a level of acceptance. The same with a pea-based burger, that the same, you maybe have other type of roasted hay that you want to mask, and you do exactly the same to identify what is the combination of the masking. The spirulina base is a fantastic product in terms of nutritional value for the consumer, but the fishy notes and the earthy and seaweed are not very well accepted. So we succeed to create through this system the right masking to have an acceptable product with a nutritional benefit. And the mycoprotein is very good in terms of taste, but when you put the flavor disappears in the matrix. So you have to consider that maybe the flavor could be added if it is a burger through the fat base, or it's important that you regulate the flavor release, maybe through encapsulation can be as well. So this is the mycoprotein that we're talking about. The name of this filamentous fungus is Fusarium venenatum. So when you read all of this, for the consumer, it's very scientific, and the people who are in science can understand, but consumer still need to accept this type of sustainable protein. And simple label, remember that when we talk about a burger, can be beef meat, salt, and pepper. And then if you go to a plant-based burger that contain the protein source, fiber, hydrocolloids, flavors, and a lot of ingredient there to create a structure, that will be less accepted. So it's important to keep the labeling simple. So what are the consumer aspirations on this? Natural, organic, minimally processed, reduced list of ingredients, source that they can recognize and understand, and sustainable. So as a summary, then we can have an opportunity, Marcio, for a question from the panel. We are moving to a diet with greater amount of plant-based food. So first conclusion, a diverse range of alternative protein you are probably seeing already in your own market. They are available to transition from animal protein, meat, dairy, egg, to a sustainable source of plant-based and mycoprotein or hybrid option. This new vegetarian or vegan product consider combination as well of plant-based protein and mycoprotein as better option from nutrition, because you can handle better the availability, sustainability, animal welfare, cost, and sensory quality. The natural flavors with masking properties give the opportunity to develop highly palatable plant-based food, and the clear, simple, and transparent labeling is critically important to help consumers understand. Luckily, natural flavor is well accepted by consumers and then can be used in the solution. So this is the personal story that I want to share. This is Impossible Burger that I bought in Singapore. And you see, this is a plant-based burger. And I can tell you that is even equal or better than a full meat burger. So moving to a diet with greater amount of plant-based food is possible. Thank you.
Thank you very much, Luis, for that brilliant presentation. I think it was quite in depth in terms of what will be the future. I don't know if we've got some questions, but I will just go through them. It's quite interesting because most of the audience, as I've been seeing, is from academia, and provided you are an expert, especially in the food sector, or you're an expert in the industry. In your opinion, okay, when do you think, if it will happen, that we will get to 50% of food of meat from vegetable origin, and if we will ever get to completely substituting animal for vegetable, and how are we going to change the minds of some people that are purists and don't believe in this?
Yeah, thank you, Marcio, for the question. Actually, I am part of a consortium that is based in Europe, but with a global approach. There are an affiliate in America and also in Asia that has a dream, a target that is by 2030, the intention is to have a ratio of 70% plant-based and 30% animal-based. So that's the target. It's good to have a target because you never know when it can be achieved. And maybe when you get to 2030, it's still not get there, but it's good to know meat or not meat below expectation, then you can put another target. So moving to 2050 with this 10 billion population in areas of the world, and sustainability is important and the availability as well. Clearly, the emergency will be coming more and more and higher pressure, but it's good to be proactive. But if the taste is right, the price is correct in the market, and you enjoy eating the product, we believe that will be the best way to get adoption.
Exactly. Thank you. I believe in that, and I think it's very good. But in 10 years, we will change 70% of the industry. That's a big target and a good target for us and for the environment. We have a question from Dr. Bruno Melgar. From the sensorial points of view, would you consider off notes or the main rejecting points for the general consumers, or texture would also play a key role in this? So texture or only the off notes?
It's a fantastic question because they are both very correlated. We are a flavor house, so we put a lot of focus. It's good to have a specialist as well. We discuss with our texturant producers to understand what is the best way to generate the right texture. But actually, that's why I talk about open innovation, because you need to combine expertise there. So we put focus on taste because this is our key expertise, but both are critically important. So I could say both. Cannot just say having the right taste and not the right texture will be accepted. It has to be both together.
And he has a follow-up question. How complicated is the texture composition considering market is expecting cleaner labels? And I would also attach a question that I have, which is, so when you use compounds to mask the flavor, are they basically, probably it's an industrial secret, but just to know if they are basically natural compounds or synthetic compounds? No, because of these clean labels.
Yeah, basically because of the trend that is clearly, particularly in Europe, the condition is to have a natural flavor. To have a natural flavor, you can use molecules produced by fermentation or enzymatic treatment or by extraction from botanical source. So there are several rules to comply with the natural flavoring, and is one of the key constraints on the final flavoring, to have a natural flavor status there.
Okay, I don't know if there are any more questions. I don't think there are.
I may add one topic, that is the fact that the labeling, when we talk about the challenge and so on, the soy burger or the soy milk, there is a lot of restriction more and more, but what is happening is that the animal protein as well are discussing how do we position this new product in the market. And to me, it's an opportunity that this plant-based food can be having their own labeling and can be recognized by the consumer with a particular plant-based name, because they are special. As it was mentioned earlier, there is polyphenol, there is fiber there, and it's good that they can be accepted as the unique product and not asking permission to the animal-based product to be in the market. They have to convince consumer by taste, texture, and the nutritional benefit and sustainability.
Do you have any backlash or resistance from the meat industry, or are they on board to change their business, their way of making money? Are they willing to change, or they resist this and try and stop this trend?
They are willing to change because the consumer move is there, and then you see more and more meat companies or dairy companies creating some unit related to the plant-based solution, either in the meat analog space or in the dairy analog space. So even the traditional meat and dairy players are having this unit as well.
So I think now with our little conversation, we are starting to get some more questions. This is Jacques Massé, and he says, masking off note is one thing, but what is the final objective? A bland product, a meaty dairy profile adding more flavor, or a good new plant flavor going away from the dairy meaty standards? So what is the objective of masking these off notes?
Okay, thank you, Jacques, an old friend from the industry as well. And so the intention on the masking is to have a neutral base that you can have, that you will not add the real flavor that you might have, pepper or roasty, that you want to have in the final product, to mask. So the mask is happening to have real, a kind of neutral base, and then you can put the right amount of the spicy notes or the beefy note that you want for the consumer acceptance. So masking is to really clean the off note that can be there and will be disturbing the release of the actual flavor. And the molecules are natural. I mean, the composition, you say, is a kind of trade secret, and it's true, but they are molecules that everybody recognize on the structure, aldehydes or polyphenol, so the molecules that are well known, no? But the combination is the key secret to get it right.
Exactly, the combination is the sweet spot of mixing 3 or 4 different compounds to get that perfect texture and flavor.
Yeah.
Luis, I would be here another couple of hours just speaking to you with all that knowledge that you and the nice way you can convey your ideas. In the name of the whole organization, I would like to thank you very much for the keynotes, and hoping to see you sometime either virtually or personally. You will have to definitely come to visit our research center and our Polytechnic Institute.
And Marcio, as you know, after we get to know in this virtual Congress, we initiated as well a cooperation, something that I fully endorse and recommend, the association with a research organization like yours, more academic approach that work together with the industry to accelerate the solution that we are looking for. So I'm very happy that we initiate this contract of collaboration with your organization in Braganza, and we can keep working together.
So are we, Luis. Thank you very much for the kind words. We will be improving on this collaboration in the future, and we will be sending the results which are just about coming out.
Looking forward.
Thank you very much, Luis, once again. Thank you, everyone that has been with us since this morning. Right now, we have 111 people. During the day, we were up to 190 watching on YouTube. So I would just leave some notes for the day. Once again, the poster sessions are on the website of the conference. Please go there and see. And if you have any questions, we can put your questions to the authors of the posters. And tomorrow morning we will start with keynote number 7 at 9:30 a.m. with Dr. Ana Oliveira. So for today, I think we are all set. I would like to thank everyone that gave speeches today, that was with us, and especially Luis. Thank you once again, and it was nice to meet you. See you. Nice to meet you again. See you, tomorrow, everybody, and thank you.